Good evening, and I welcome you, students. You are back. Let us release the stress before we begin the session. Sit comfortably, and we can do inhale and exhaling Vastrika. What we do? 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, come back. Come back. Right hand, inhale, exhale. Stretch the neck to the right side. 1, 2, 3, 4, 5. Exhale, come back. Left hand, inhale, exhale, hold. 1, 2, 3, 4, 5. Come back, exhale, release. Neck to the right, inhale, exhale, inhale, exhale, inhale, exhale. Breathe in, breathe out, breathe in, up, breathe it down, breathe in, up, breathe in, down, breathe in, up, breathe in, down. Now, neck rotation, 3 times clockwise, 3 times anti-clockwise. Release all the stress, stiffness from the neck. Spinal cord should be erect. Half inhale and half exhale. Start. Clockwise rotation. Anti-clockwise. Come back, shoulder. 3, your shoulder rotate. 1, 2, 3, 4, 5. Reverse. 1, 2, 3, 4, 5. Okay, come back. Tap your feet 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Experience the vibrations, experience the flow of energy, experience the circulation of blood in the entire body. That is the idea. That is the idea. We should release ourselves. Now we'll do a breathing to relax our mind, get rid of the distractions from the mind, negative energies, so that we can focus, concentrate on the topic and question answer sessions. You can close your eyes and you can do deep breathe in from the nostril, and then you will bring your awareness to the third eye between the two eyebrows, one of the chakras, which is very important, and release a sound of honeybee sound. So bee sound. The name of the honeybee is Brahmari, which is a important bee. We will use that. It releases the stress and relaxes our mind. So sit comfortably, close your eyes, spinal cord erect, feet should be touching the grounds. Relax and breathe in as deeply as possible and bring your attention to the third eye, which is between the two eyebrows, the chakras. This is very important, and we will release with a zoo sound. That is the Brahmari bee, which is important. Okay, this will give a good relaxation. Start. Breathe in. Take your attention to the third eye and sound of zoo. Zoo. Breathe in. Zoo. Inhale as deeply as possible. Last time, inhale as deeply as possible. Relax your mind, relax your body, and take your attention to your breath. Observe your breath. Inhale, exhale, inhale, exhale. Fold your hand. Attitude of gratitude is very essential. Fold your hand. Prayer to the God. We thank you, God. We thank you, universe. We thank you, environment, for all the gifts which we have. We have water, we have food, we have houses, we have schools where we are studying. We thank you, thank you, thank you. Now you can rub your hands. Slower, faster, faster, faster. Now experience the heat energy, healing energy, and like a field of the magnet, put it on your face. Keep inhaling, exhaling. Observe your breath, observe your breath. Pay attention to your breath. Gentle massage your face, eyebrows, cheeks, ears, neck, your head, and you can open your eyes with smiles and clap. 1, 2, 3. Okay, come back, come back. All right, we are back to the game. Energy levels high. Set up an intention that we will focus, we will concentrate, and we will dive deep inside. Immerse yourself in what you are studying, students. Whatever you study, immerse your mind, immerse your body, everything. Pay attention, pay attention. It helps us a lot. There should be no distraction, and energy should be high. Always keep yourself inspired, motivated by high energy. Higher the energy, more energy you will attract, students. All right, let us see some of the important question answer sessions. And the question number is coming. Intermolecular hydrogen bonding. Again and again, as I said, certain questions are coming which indicates that such questions are going to be asked on intermolecular hydrogen bonding, intramolecular hydrogen bonding, and is strongest in methylamine, phenol, formaldehyde, methanol. Methylamine, phenol, formaldehyde, methanol. At least you draw the structures of these. After you will be able to draw the structures of these, you will be able to get an answer. Draw the structures of these. First, we should always draw the structures of these: methylamine, phenol, formaldehyde, methanol, and then you try to see in which case you will have strongest intermolecular hydrogen bonding. There are two types of hydrogen bonding: intra and inter. What is the draw the structures? Methylamine. Methylamine, students, you have C, H, 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 N, H, H.
Sir, it should be methanol.
You have phenol, phenol, students. You have formaldehyde formula
HCHO.
and then you have, students, methanol is a CH3OH. Now, which case you have the highest charge separation? Which case?
In methanol.
Methanol.
Yes, sir.
So what will happen? This is positive, this is negative. This is methanol. Intermolecular hydrogen strongest in methanol. Oxygen is more electronegative. What is the difference? This is hydrogen is not. What happens here? What happens here?
Sir, in case of phenol, there will be steric hindrance.
This group is a bulkier group.
So yes, sir, there will be steric hindrance.
This is a electron releasing group. What happens? There is another effect which is operating here. What will happen if it takes place? The negative charge will be withdrawn and then the result will be, it will have less negative charge, it will have more negative charge. So the separation of charge is more here, the methanol. We have to look into all the possibilities, whatever we know, students. More electronegative element, less on what other factors could be there when hydrogen bond is formed. Next question is coming. In AgCN2, the number of pi bonds is AgCN2. Is it a complex?
Yes, sir.
Complex. Then what will happen in this case? Number of pi bonds.
So there will be 4 pi bonds.
4 pi bonds. How do we say that?
The
What is the
structure, we'll draw the structure.
what is the oxidation number of silver?
+1.
What structure you are drawing?
In case of CN, there will be 1 sigma and 2 pi bonds. There are 2 CN groups. So there will be 4 pi bonds.
1 sigma and 2 pi. How many? 4 pi bonds.
Yes, sir.
Okay. Next question is coming, student. Barium sulfate is insoluble in water. Barium sulfate. We have seen the precipitate of barium sulfate in the chemistry.
Yes, sir.
What is that precipitate?
White colored PPT.
What is the test which you do? It is used in salt analysis.
Yes, sir.
What we see, what we do. We have barium ion and sulfate ions.
So we add potassium chromate in the solution dissolved in acetic acid. Yellow PPT of barium is formed. Then we'll get for barium 2 plus
talking
conformation.
of the test of sulfate ions by adding barium chloride. What you will get?
BSO4.
What is the color?
White PPT.
And it is not soluble. Why it is not soluble?
Because it has very high lattice enthalpy and low hydration enthalpy.
All right. What is lattice enthalpy, students? There will be questions on that. What is lattice enthalpy? What are the factors on which lattice enthalpy depends? High lattice energy, we know about it. That is correct. It will have a high lattice energy. That means what energy required to dissociate is very high. What is the lattice energy depends on what are the factors on which lattice energy depends?
It will depend upon the charge of the ion and the size of the ion.
Charge and size ratio. All right. And what happens to the hydration enthalpy?
Hydration enthalpy is less.
Less. And these two reasons, then what is the correct answer?
So both A and C. D.
Both A and C. All right. There will be questions, some questions, as we have told you about lattice energy, hydration enthalpy. Their solubility is a great important factor. There are two things, hydration enthalpy, and we have also discussed Born-Haber cycle, important. Hydration energy. All this is important. Some questions could be there in the exam based on that. Next question is on the screen. Acetylene. So you have to draw the structure of acetylene and find then how many sigma and pi bonds are present. They can give a bigger molecule in the exam than this and ask you to find sigma and pi bonds. Acetylene. They can ask to form sigma and pi bonds.
It will be 3 sigma and 2 pi.
This is sigma, this is sigma, this is sigma, and 2 pi. 3 sigma and 2 pi, which is the correct answer?
3 sigma and 2 pi. It's C option.
All right. This is a simple molecule. They'll give you a bigger molecule where they can ask you to find. Next question is coming on the screen. Which of the following statement is true? Hybridization of the central atom in NH3 and CH. Is there some mistake here? There is some mistake here. Let me CH4 is sp2. BeCl2 has a V shape while SO2 is linear. Which of the following statement is true? True. SF6 is octahedral. Fs bond angle is 90 degree. Carbon dioxide has a dipole moment. Okay, find out. Read the statement carefully and try to see which is correct and which is incorrect statement. What is the hybridization in ammonia?
sp3.
sp3. What is the hybridization in CH4?
sp3.
Is it true or false?
False.
False. BeCl2 has V shape while SO2 is linear. What is the shape of BeCl2?
It is linear. BeCl2 is linear.
Linear. What is the hybridization?
Hybridization will be it will be sp.
sp hybridization. What about SO2?
SO2 has the hybridization of sp2.
Sulfur, how many? 6. 1, 2,
6.
3, 4, 5, 6. One oxygen takes 2. So what is that? 2 bond pair and 1 lone pair.
1 lone pair.
sp2. Then what is the geometry of SO2? What will be the shape then?
It is bent or V shape.
Bent, because 1 lone pair is there. There is a lone pair. Okay, this statement is true or false?
False.
False. Next, SF6 is octahedral. What is SF6?
This is true.
What is the hybridization?
sp3d2.
sp3d2. And then what are the bond angles? No answer be given without solving the question. That's my point. Don't try to guess
It will be 90-degree bond angle.
S. And what you have, students? 90 degree. Yeah. Then is it a true statement?
Yes, sir.
True. Carbon dioxide has a dipole moment. Is it true or false?
It is false.
What happens in CO2?
They will cancel each other.
Cancel each other. What is the hybridization in CO2? All questions are being varied by me because they can ask anything.
SP. It will be SP.
How do you say how many bond pairs? What is carbon? 1, 2, 3, 4. You see how easy it is. One oxygen will take 2. One
Two.
oxygen will take 2. So
SP.
2 bond pair. What is the lone pair?
0.
0. So what is that? SP. See SP, how easy all this work becomes now. Questions could be anything. I'm not saying that this question is coming, but why I take this question, I can make 5 questions of that. How much work we have done, you can see. Without solving everything is a question itself in the paper, student. You must go in detail. We're not going to make any guesses, so be careful. Next question is coming then. What is the answer here? Then 2, this is false. Okay, next question, students. BF3, NF3 are covalent, but BF3 molecule is non-polar, while NF is polar. Again, an interesting question now. What are the choices? And read it carefully than before. Atomic size of boron is smaller. BF3 is planar. NF3 is barren. Boron is a metal, while nitrogen is a gas. BF has no dipole moment, while NF has bond has dipole. What is the answer coming, student? Read every statement carefully. Every statement will teach you something and revise some part of the chemistry. All right, water, heal me. Sip water, students. Okay.
It should be BF3 is planar, but NF3 is pyramidal.
Atomic size of boron is smaller than nitrogen. What it makes sense? Is it smaller? When I talk of size?
No, sir.
No, sir.
No, it is boron. Yes, sir, it is smaller, but it is not applicable here.
That is what I'm saying. I'm not saying that whether statement has no connection with what? That what is saying covalent, polar and non-polar, non-polar and polar. So this is not the correct choice. BF3 is planar, but NF3 is pyramidal. What will be the result of this on polarity? If it is planar, what will happen? Will it be polar?
It will cancel. It will cancel. So it will not be.
So, and NF3 is pyramidal. What happens then, student? You have seen. There is a lone pair also. That is the way it looks.
Yes, sir.
And what is happening to BF3? They cancel each other. 0. Dipole. It will have a net dipole. All right, this is the correct answer. Next question is coming. Other, what is that? Boron is a metal, while nitrogen is a gas. Is boron a metal?
No, sir, it is non-metal.
BF bond has a no dipole. Is it? BF bond has a no dipole. NF bond has dipole.
No, sir. This is also not correct.
Okay. Next question 44 number is coming. The boiling point of alcohol is high due to boiling point of alcohol. Boiling point questions are favorite questions in the paper, but different type of boiling points questions are given. They may give series of compounds and ask you to find the boiling points and arrange them in ascending or descending order. Melting points, boiling points, these questions are being asked students. All right, what is the answer coming?
It is hydrogen bonding.
Okay, there's no other. Hydrogen bonding. Okay, large size of alcohol has meaning presence of OH group, but I will say high molecule. That do affect to those, but here alcohol in the case of alcohol. When we compare, then story will be different than the molecular weight comes here. This is the only appropriate answer. Next question. The hybridization of I in IF3. IF3, and what is it? IF3? Or IF5 or IF3?
It is IF3 only.
IF3. Okay, find out what is that will happen in IF3.
It will be sp3d.
How many electrons in iodine?
7.
1, 2, 3, 4, 5, 2, 4, 5, 6, 7. How many fluorine? 1, 2, 3. How many lone pairs?
2 lone pair.
2 lone pair. How many bond pairs?
3 bond pairs.
Total 5. Then what it becomes, student? sp3d. 3 plus 1, 4,
Yes, sir.
5. sp3d. What will be the shape of this? The shape has been asked many times. Important question, student. What is the shape of?
Geometry will be trigonal bipyramidal and shape will be T-shape.
That's important because what happens in this case? Where will be the lone pairs? Where will the lone pairs go? What is this angle? 120 degree.
Yes, sir. 20.
120 degree. It's something like a bent T shape, slightly. Similarly, you know the shapes have been asked for BRF3, CLF3 many times. CLF3, BRF3, they are very normal questions have been asked many times in the paper. The interhalogen compounds shapes have been asked many times. Different type of interhalogen compound we have studied. What we have studied? What type of compound is this?
Interhalogen.
And you have seen there are so many. And you have seen their structures and shapes have been discussed in a tabular form. That means when it is a table, it is important because there is so much questions in that. You can put up different questions on that, or you can try to revise all. Okay. Next question is coming, students. What is the number of sigma and pi bond present in molecule of sulfuric acid? Sulfuric acid, student. Then you should be able to draw the structure of sulfuric acid. Sulfuric acid. Can you draw the Lewis structure of sulfuric acid? Or what is the hybridization of sulfur? Sulfuric acid. Oxo acids of sulfur. Oxo acids of sulfur. Did they give the shape of that? H2SO4.
Yes, sir. H2SO4.
How do you draw the H2SO4? H2SO4. How will you draw it, students?
It will be 6 sigma and 2 pi bonds. A.
What is the hybridization?
Hybridization will be sp3.
Sulfur. How many electrons? 1, 2, 3, 4, 5, 6. What type of bonds are present in sulfur? How many OH bonds?
There are 2 OH bonds.
And then there are 2 oxygen atoms left. This is oxygen. This is oxygen. OH single, OH single. Is that the thing? Am I right?
Yes, sir.
The total becomes how many?
Then it will be 1, 2, 3, 6 sigma and 2 pi.
4 bond pairs. So how do you write sp3? I have to do it, student. Now, what is the story? How many sigma? 1, 2, 3, 4, 5, 6 sigma. Huh? How many? 6 sigma. And how many pi?
2 pi.
Where is that?
1 here and 1 will
Structure.
be.
They can ask the structure. Very important structure. Oxoacids of sulfur, I have written now. All oxoacids of sulfur, even the names sometimes are not, we are able, sure. Sulfurous acid, sulfuric acid, and what others? Name the oxoacids of sulfur. Oxoacids of sulfur, student, important.
Sulfurous acid, H2SO3,
Then
H2S2O7,
what is that? Their names, oleum and others. So many are there.
H2S2O6, dithionic acid.
Now they must be learned by all the students. Oxoacids of sulfur and oxoacids of phosphorus are very important. Oxoacids. Questions are always asked on that structure. Oxoacid sulfur hai, phosphorus hai, nitrogen hai. All this important. Then we have talked of halogens also. Halogens. All this, there is so many variety. Next question. Next question. This is to be learned by all the students. Phosphorus we have done. A separate lecture is there on the oxoacids of phosphorus, oxacids of sulfur, nitrogen, all these very important questions. Next question, the shape of IF7 is IF7. Okay, write and do it. What is going to be the hybridization?
It should be pentagonal bipyramidal.
You are again and again interhalogen compounds. They are very important for exams. And the most important questions are asked on the structures of interhalogen compounds and hybridization. How many are there in iodine?
There are 7 electrons.
3, 4, 5, 6, 7, and 7. Fluorine. What it makes?
sp3d3.
Bond pair 7.
Yes, sir.
sp3
D3.
d3. What is that? Pentagonal?
Bipyramidal.
Trigonal? No. Pentagonal bipyramidal. And one xenon compound also we discussed something like that. There, what was the shape of the xenon halides? They have asked repeatedly their shapes and structure. Xenon fluorides you have seen. There is a table for the non-fluorides also. That should also be learned by the student. Whatever that XCF2,
XCF4, XCF6.
and also
XZOF4, XZO2F2.
XCO.
F4, XZO2F2.
All these important. Very important. One of the questions will be there. Repeatedly asked questions in the paper. We have to learn the trick to be able to answer question. We have shown you so simple trick. You can use that and apply. Most of the cases it works. And don't have spend too much time on that. The highest dipole moment is of, okay, draw the structures, shapes of the molecules and see the electronegativity difference. Then only answer the question.
It will be CH3FD.
Highest dipole moment, student. What happens in CF4?
CF4 and CH4, they have tetrahedral structure, so they will cancel.
What is the
Symmetrical
dipole
structure.
moment of this? What is the dipole moment of CO2?
CO2 will also cancel 0.
0. What? Only these two are left. These two
Yes,
are
sir.
already out. We know about it. What is the shape of this CH3F?
CH3F will be more dipole moment because F is more electronegative than
I'm saying,
oxygen.
what is the shape of this CH3F?
Tetrahedral.
What is the problem here? You already know, student. What we are doing.
CH3F.
So this is the most electronegative here. What is the shape of CH3OH?
C, H, H, and then OH. It will also be tetrahedral only, and OH group and 3.
Carbon is sp3. Carbon is sp3. What is the problem I gave you? Because there should be no confusion. Carbon sp3. So what will happen, student? You know what is happening. See that we try to do detailed study of everything. There is here the central atom is carbon in all the 4 cases. Question is clear. He is talking of carbon as the central atom. So we have to see what is the hybridization. And that CO2 already we know what is the, so much we are discussing about CO2 again and again. So what is the, this is the right answer. Okay, no problem now. Next question is coming. The most polar bond is the most polar bond is. Now the electronegativity difference we have to see. Electronegativity difference we have to see. As we say, we have already said to you that you must learn the electronegativity table. Not complete, but most important part. The values are given in a table, electronegativity values. So that when 2 atoms are there, we have to see what is the largest difference in the electronegativity, and the answers can be given them.
The most polar bond OH, CO, CC. OH, A.
The electronegativity difference is where maximum. These 2 are out. Okay? Only 2 are left.
Yes, sir.
Now the question is, one is hydrogen, other is carbon. So which has a lower value of the
Electronegativity difference will be more in case of OH.
OH. What is the value? You have any idea of the two values? What is the electronegativity of oxygen, hydrogen, and carbon? Now the question comes to that.
For oxygen, it is 3 point something. I guess 3.4 something.
We can't say something because that makes all the difference. We have to, because they, in the table they have given you
For
how,
hydrogen, it is 2. For hydrogen, it is 2.
how it is to be learned, student. You have to see. If it is carbon is more than hydrogen something, and we know it is around 3 point. If it is 3.5, it is 2, and it is 2.1 or 2.2. Some values have been given. It's important to know it and read them carefully. Read them carefully. Sometimes it may look to appear something, but then when you don't know the actual values, there could be problem, because 4 of the 2 choices are always bad. Only 2 will be left in most of the questions where you have to apply your mind. All right, then learn the electronegativity table Pauling scale. Next question is coming, student. Which one of the following is correct said with reference to molecular formula, hybridization of central atom, and shape of the molecule? There are 3 things: molecular formula, hybridization, and shape. Okay, try to find all the cases which are given and then answer the question.
So for correct, it should be BeCl2 Sp linear. It should be C only.
What is CO2?
CO2 is Sp hybridized.
Wrong. Okay.
Yes, sir.
Water?
It is Sp3 hybridized.
Okay. BeCl2?
BeCl2 is Sp.
Sp linear. Okay. Water?
It is Sp3, but it is tetrahedral in shape.
Not linear. All right. So, all right. Instead of in one question, they have asked more than 2 things. They can do it. One is very easy question, then they will put 2 or 3 things together. Then we have to think more. Next question is coming. What is the hybridization state of central atom in the conjugate base of ammonium ion? Conjugate base of ammonium ion.
It will be Sp3.
What is the conjugate base of ammonium ion, student?
NH3.
This is an acid. Then it will lose. Acid loses a proton, and what it forms? Conjugate means.
Yes, sir.
Okay, and then we already know about it. Okay, where is it? Okay, sp3. Which one of the following molecules contain both ionic and covalent bonds? Student, ionic and covalent bonds. I'm talking of two types of bonds: ionic bonds, covalent bonds, students. And you should know about them. What answer you are giving?
Sir, it should be K2SO4.
What happens in this case?
K plus and SO4 2 minus ions. So there will be ionic bond, and between S and O there
What
will
are
be
the bonds in CH2Cl2?
they will be CH2Cl2. They will be covalent.
What is here? What are the bonds here?
Covalent.
What happens in potassium ion and SO4 2
SO4.
ions? This sulfur has what type of bonds? Sulfur and oxygen. Covalent and ionic both. So be careful when answering the question. Next question is coming. Which one of the following is correct set respect to molecular hybridization and shape?
Sir, it should be C option.
What is BCl3?
BCl3 is sp2 hybridized.
And shape?
Trigonal planar.
Trigonal plane. You can draw for all of them and see.
Yes, sir.
This is sp2 BCl2. Wrong.
Wrong.
sp2 triangular plane. BCl3 sp2 triangular plane. Okay.
This is correct.
All right. Third is next. Which of the following shows isostructural species? Isostructural species. What do you mean by isostructural species?
Which have the same shape. Sir, it should be C option.
C option. Okay. Next question. Which one of the following is a planar molecule?
It should be
You already know about
BCl3.
done it so many times. I don't want to spend more time because this question is now the questions which are becoming difficult in the beginning. Now they look to be easier because you're doing so much practice. Next question: the molecule have the largest dipole moment among the following.
Should be yes, I see. This is 4 and this is 0. Sir, it should be CHCl3.
All right, that we know so much now. No need to explanation. Cl is the most electronegative elements, and these are symmetric molecules. Next question is coming. Compound oxygen and hydride of sulfuric acid. The number of sigma bonds and number of pi bonds present in X are. And hydride of sulfuric acid. Anhydride.
Anhydride. That should be
What do you mean by anhydride, student? Know about it now.
SO3. It should be.
How many sigma and pi bonds?
Will be SO3. So 1, 2, 3. 3 sigma and 3 pi.
All right. Now we are knowing what we are doing. Next question. Which one of the following is a correct set?
So it should be
You already know what is the problem. You already know.
A option. It should
The
be.
option. Okay. Next question. Sulfur reacts with chlorine in 1:2 ratio and forms X. Hydrolysis of X gives sulfur compound Y. What is the hybridization of central atom in the anion of Y? In the anion of Y.
Compound water represents the state of central atom in the anion Y. So it should be sp3.
What happens in this case?
It will be S plus 2Cl2 will give SCl4.
Then what is the product on hydrolysis?
On hydrolysis, it will give SOH whole 4 and then H2SO3, which will be Y.
What is the hybridization state of central atom in the anion of Y?
sp3.
Next question, how many sigma and pi bonds are present in toluene? What is the structure of toluene?
One, two, three, four, 2, 3, 4, 5, 6, 7. 3, 4, 5. 3 pi and 8 sigma. D.
8 sigma.
Yes, sir.
How 8 sigma?
1,
Pi,
2, 3,
3 pi
4,
I
5,
can see.
6.
6 sigma, to this one,
Yes, sir. 6.
and 6.
3, 4, 5, 6, 7.
1 sigma, 2, 3, 4, 5, 6. 6, 7. There is this also. Hydrogen. 1, 2, 3, 4, 5, and 6, 11, 11, 12, 13, 14, 15.
15. A. 15.
3 pi and 15 sigma bonds. All right. Then this ends up the session here. We will continue more in our next classes. Okay, then I see you next time. Okay, bye bye.
Okay, thank you, sir.